Hello everyone, I'm Vivek from K4Metrics and we support SmartUQ in India. In this video, we'll be covering the concept of confidence interval using the option of display variance in SmartUQ. A confidence interval is the mean of your estimate plus and minus the variation in that estimate. So, this is the range of values you expect your estimate to fall between. So, here I have opened the input and output simulation parameters for Naka airfoil, and this is the surrogate model, or what we call in SmartUQ as emulator. So we have done a series of videos covering how you can get the input values from SmartUQ, how you can obtain the output from a CA solver, how to create the surrogate model and do further studies. So I leave the playlist link in the description. So if you are new to this channel, you can check out those videos. Now coming back to the topic. So this is the surrogate model, and I would like to show you the confidence interval part. So for this, I'll go to the surface view. Here you can see in the two axis here it is showing the input parameters, that is M and P. The parameters can be changed from here, that is for X and Y axis. Here the Z axis is showing the output value, that is the coefficient of lift. Now if I scroll down a bit here, I can see the option called display variance. So when I turn on this, so you can see two gray surface has come in the graph. So let me just increase the opacity so that it is clearly visible in the video. So now you can see the two surfaces which are the upper and lower bounds here. So let me rotate it so that you can see this clearly. And the confidence interval that has been set here is 0.95. That is the 95% here. You can change the confidence level depending on your requirement by changing the value here. So what it is basically saying is that the coefficient of lift, that is the output of the simulation, for 95% of simulation runs will lie between these two upper and lower bounds. So this is a great way to obtain confidence in your design and the input bounds that you have taken for your input parameters. So a similar way of obtaining the confidence interval in multi-view is, before going that, multi-view is an interactive plot which shows the relationship between the input and output parameters. So MPT and alpha are the input and CDCL are the output parameters here. Now if I scroll down again, the display variance has been turned down and it is set to again 95%. So here the value for CL is shown as 1.05. So this is the prediction value by the emulator for these four input parameters. And at the top you can see the 97.5% quantile, the value as 1.08, which basically means that for 97.5% of the cases, the value of CL will lie below 1.08, and for 2.5% of the cases the value will lie below 1.02 in turn, meaning that for 95% of the cases the value for CL lie between these two values. You can view that upper and lower bound how I show in the surface view here as well. So let me just expand this so that I can view it clearly. So you can see these two thin lines here. So if I hover my mouse on the upper line, so you can see the 97.5% quantile here. If I scroll to the lower one, you can see 2.5% quantile. And if I go to the center line, that will show the mean or the prediction by the emulator here. So as I mentioned earlier, this is a great way to increase confidence in your design, especially the bounds for your input parameters that you have taken for your design space. So this concludes this video. So if you have any questions on this, you can drop a comment down or reach out to us at support@k4metrics.com.